So when two shapes are congruent, their sides and angles are exactly the same. So in the case of triangles, the same theory applies. If you place one triangle over another and it overlaps the other triangle exactly, then we call those two triangles as congruent triangles. We can look at some examples over here and try to see if those shapes are congruent. So first let's select the second triangle and try to move it and see if it overlaps the first triangle, and as you see it overlaps it exactly. So these two triangles are congruent. But in this case, if you observe, this triangle and the first triangle seem to be in different orientations. Let's try to rotate this triangle and move it, and now as you observe, these two triangles overlap each other exactly. So these two triangles are congruent. Similarly, the blue triangle can also be flipped vertically and you'll observe both the triangles are congruent. However, if you observe, this green triangle is not congruent with any of the other triangles. Even if I rotate it, it will not be overlapping the other one because it has different dimensions. So going back to the earlier statement, if two triangles have to be congruent, they have to overlap each other exactly. And if two triangles are congruent, then the corresponding sides and angles of those two triangles will be exactly equal. So in the earlier lesson, we have seen that in the case of circles, we just need the radius of the circle to determine if the circles are congruent. Similarly, for squares, we said that the side of the square, and for rectangles, we need length and breadth. So what about triangles? So triangles have three sides. How many sides do we need to know in order to determine if two triangles are congruent? Let's see. Let us assume that we know the dimensions of a pair of corresponding sides of two triangles. Will that be sufficient to say if two triangles are congruent? Let's see. So in this case, the triangle ABC and DEF, we have two sides BC and EF, the corresponding sides of two triangles, which are equal and they are x centimeters in length. So with this information, I can draw different types of triangles as you see here. So AB is not equal to DE and AC is not equal to DF as you observe. And if I try to move triangle 1 or rotate it or flip it and try to overlap it on the second triangle, they will never overlap exactly. So knowing one equal side is not enough to say if two triangles are congruent. So now let's assume that we know two sides of the triangles to be equal. Will that be enough to say if two triangles are congruent? So for that, we need to do some construction. First, let's draw a triangle ABC. And now with the center at B and the radius equal to AB, draw an arc like the white one as you see here. Now take any point on the arc and join it with B. So here I have taken 2 points D and E and I have joined them with B. And now connect D with C and E with C. You will see that it forms three triangles ABC, DBC and EBC. Over here we have two sides which are equal. BC is the common side, so that will be the same, and then AB, BD and BE are all equal because they are the radius of that arc that you have drawn. So now in this case we have three different triangles with two sides equal. So then the third side is not at all equal in any of these three triangles. If I try to move, rotate or flip any of these triangles and try to overlap it with the other, I will not be able to do that exactly. So knowing two sides is not good enough to determine if two triangles are congruent. What if all the three sides are equal? Let's try to see that. So now let's try to draw a triangle ABC with BC being x centimeters, and with center B try to draw an arc like in the white with y centimeters radius. Now with center C draw an arc of z centimeter radius. The point at which these two arcs intersect is A. Now join AB and AC. You will form a triangle with three sides whose lengths are x, y and z. There can only be one unique triangle with these three lengths because there is no other place where these two arcs will intersect. there will be only one unique point at which these two arcs intersect. So if I try to construct another triangle with the same procedure, I will always end up with the same triangle. So it means that if I know all the three corresponding sides of two triangles are equal, then I can say those two triangles are congruent. So they will overlap each other exactly. And because these two triangles are equal, their angles are also equal.